Friends, in this video also, welcome back to our YouTube channel Mechanical Engineering Exams Made Simple. Friends, in this video also, let us see some important questions from IC engines, internal combustion engines, combustion phenomena, petrol engines, diesel engines, etc. Okay, friends. So let us see the first question. First question: during combustion of gasoline in the engine, what happens? Some of the gasoline does not burn. So actually, in the US it is called gasoline. In our India it is called petrol. Right. Second one, some gasoline only partly burns, producing CO. Right. So basically, any fuel consists of basically hydrocarbon. So when it reacts with oxygen in the air, it is going to form carbon dioxide and water. If sufficient oxygen is not available, it is carbon dioxide is not going to form, but carbon monoxide is going to form. Let us see. Third one is polluting gases exit from the tailpipe, that is exhaust pipe. All of the above, what happens? So actually, all of the things should happen, friends. Some of the gasoline does not burn, right? And some gasoline only partly burns, producing CO. Just now I told you, it is only incomplete combustion. That's called incomplete combustion. Third one, polluting gases exit from the tailpipe. Not only carbon monoxide, some nitrogen oxide, NO, N2O, something like that, NO, NO2, they are called NOx, and COx, CO and CO2. If CO2 is formed, no problem, we don't have any problem. But CO, it is not to be inhaled, it is very dangerous, it is carcinogenic, okay, causing cancers. Now, SOx, sometimes if your fuel contains sulfur also in some quantities, it is going to mix with oxygen in the air and going to form SO2 or SO3, they are called SOx. And of course, unburnt hydrocarbon is always there. So, which is not burnt, hydrocarbon which is not burnt, they are called unburnt hydrocarbons. So, all of these things are going to happen, friends. So, let us see, analyze more. So, what happens actually during the combustion of gasoline in the engine, the burning gases get very hot. Yeah, definitely. The temperature may go as high as 6000 Fahrenheit. So, this comes around 6000 minus 32 into 5 by 9. It is going to come around 3320 degrees centigrade, friends. Now, this high temperature produces the pressure that makes the engine run and produce power. So, this particular pressure is going to be the cause of the what you call pressure. This makes the engine run and produce the power, mechanical power. That is the power available at the crankshaft. Now, with ideal or perfect combustion, all of the hydrogen and all of the carbon in the gasoline, just now I told you, any fuel is the hydrocarbon. It is a mixture of hydrogen and carbon basically. So that will combine with oxygen to form harmless H2O, water and CO2, carbon dioxide. However, in the engine, we don't get ideal combustion. That means complete combustion is sometimes not possible. Let us see why. Right. So instead, some of the gasoline HC does not burn. They are called unburnt hydrocarbons or UHCs. Also, some only partly burn, producing carbon monoxide. C plus O2 gives CO2, but C plus insufficient oxygen. Instead of two atoms, if your fuel is having or your carbon is getting only oxygen, only one atom from the your air, so it is going to form CO only, carbon monoxide, and instead of CO2. Now, the unburnt gasoline or unburnt hydrocarbons and partly burnt gasoline, CO, that's called CO, carbon monoxide, cause pollution in the air as they exit through the tailpipe with the exhaust gases. This is the reason that modern cars are equipped with anti-pollution devices. They are called emission controls. These devices reduce the amount of HC and CO coming from the engine. They are also called catalytic converters. So, these catalytic converters are going to convert the polluting elements to non-polluting elements. CO to CO2, NO2 will be dissociated into nitrogen and oxygen. So, sulfur SOx, that means SO3 and SO2 are again dissociated into S, sulfur and oxygen separately. So, individually sulfur and oxygen not harmful, but in the combined form they are harmful. Similarly, nitrogen and oxygen, if they are available separately, N2 and O2, they are not harmful. If they are, even though they are found in the atmosphere through the exhaust, there is no problem. But if they combine, if the nitrogen in some quantities in some of the fuels, it mixes, or nitrogen in the your air mixes with the oxygen in the air, in the fuel or maybe air, if it is going to form nitrogen oxide, NO or NOx, NO or NO2, they are called NOx emissions. So these are going to be very, very dangerous. So these catalytic converters, what they do, they are going to convert the harmful products of combustion into unharmful products of combustion. Right. So the correct answer is D. Let us go to next. The device that can provide control as temperature changes it. What is this device? It is called thermostat or thermometer or gravity or vacuum. Gravity, vacuum are given to just confuse you friends. It is the thermostat. So it is basically, this is about the water cooling system friends. So your water gets heated after cooling the engine because that will be circulated through jackets, and this water has to be cooled. Okay, but at certain temperature only this hot water will be directed to the radiator. So this work is done by the thermostat. So it will allow the water to go to the radiator after your water comes to certain high temperature. So roughly it is 89 or 90 degrees centigrade roughly. Okay friends, let us check anyhow. So different metals expand different amounts when they are heated. For example, aluminum expands about twice as much as iron. So its coefficient of linear expansion is double. So that is the property. And what is ultimately coefficient of linear expansion? It is a change in length by original length per unit rise in temperature. That is strain by change in temperature. Now such differences in expansion are used in many thermostats. It is a coil made of two strips of different metals. So there are two different metals. Thermostats are made of strips of two different metals such as brass and steel welded together. They are actually joined by the welding process. When the coil is heated, one metal expands more than the other. So this is the mechanism actually. This is the mechanism through which the following thing is going to happen. What is that? This causes the coil to wind up or unwind. Okay, so this unequal expansion of these two metals is going to wind up or unwind. So the motion of the coil can be used to control fluids or electricity. So this motion of the coil can be used to control both the fluids as well as electricity also, right? It is used in this manner in several places in the automobile. So your correct answer is A, thermostat. Right friends? Combustion in the engine is affected by, so which of the following factors are going to affect the combustion in the engine? Is it atmospheric pressure or changes in air temperature, humidity, all of the above? Friends, I found that if the answer is all of the above, I have found in your previous papers also, if for any of the questions all of them is correct answers, so most probably choose, but choose cautiously. Okay, not as a rule, but definitely sometimes I found that if all of them are given, all of them are found to be correct answer. Anyhow, let us check the answer for this. So now, changes in temperature, atmospheric pressure and humidity. Humidity means what? Water content in the air. So definitely your atmospheric air will have some quantities of water in it in the dispersed form. So that's why we see that in the winter we are going to see water on the leaves, on the tree leaves. Yes or no? So how this water has come? Because of the cooling of your atmospheric air. So then your water in the dispersed form in the air will be condensed onto the leaves. Right. Now changes in the temperature, atmospheric pressure and humidity affect combustion in the engine. They affect the way the fuel burns. Especially these factors are going to affect the fuel burning. That is the way the fuel burns and the power output of the engine. So definitely if the fuel burns completely and we are going to get the highest power. If the fuel is not going to burn completely, or if there is any problem in the complete burning of the fuel, it is not going to yield the complete power or full power. So accurate testing of the engines requires that all readings be corrected to account for temperature, atmospheric pressure and humidity. So they have to be appropriate for the good power generation. So the correct answer is D. Engine power is produced by what? Is it rotation of the crankshaft or combustion pressure pushing on the pistons, up and down movement of pistons, valve action? What is the correct answer? Engine power is produced by combustion pressures pushing on the piston, right? So we are going to see that, we are going to assume that the pressure developed by the burning of petrol and air in SI engines, spark ignition engines, that is petrol engines, or petrol and diesel in case of CI engines or compression ignition engines. After they burn, lot of pressure is going to be produced. So right, this pressure of the combustion gases is going to act uniformly on the piston and it is going to push. So when the piston is pushed, so it has arrangement connecting rod, crank and crankshaft. And of course crankshaft connecting rod will be having bearings and pins also, right? So through the mechanism of piston, connecting rod, crank and crankshaft. So the power is, the IP indicated power produced, generated in the cylinder is going to be transmitted to the crankshaft. The power we get at crankshaft is known as the brake power. Okay friends. So as the piston nears TDC, there are two things called TDC and BDC friends. What is the TDC? It is near to the cylinder wall. That means inward stroke. Outward stroke, it is called BDC, bottom dead center. The volume between TDC and BDC is known as stroke volume. There is some clearance volume between the cylinder wall and the top dead center position. This is going to be very useful in calculating the stroke volume, and clearance volume are going to be useful in calculating the compression ratio, which is the ratio of the volume before compression to the volume after compression. So as the piston nears TDC on the compression stroke, what is going to happen? And we are in the SI engine, we are going to, that means electric spark is produced in the cylinder in case of a SI engine. The spark comes from the ignition system. Of course, there is a special system for this particular spark generation, that's called ignition system. There are two ignition systems, friends. One is the battery ignition system and other one is the magneto ignition system. Right. So the spark comes from the ignition system. It can be any of the ignition system and takes place at the spark plug. The heat of spark ignites or sets fire to the compressed air fuel mixture. It is basically in case of a SI engine or petrol engine. By the time the piston has moved up over TDC and has started down, combustion is well advanced. Right. Now, momentary temperatures in the burning mixture may reach as high as these temperatures. Kindly have an idea, friends. So after burning, what could be the temperature? Sometimes such questions are also asked. In the SI engine, it is around 6000 Fahrenheit. That is approximately 3316 degrees. So how we have got it? 6000 minus 32, whatever it comes, into 5 by 9. The very high temperature results in a very high pressure. This is an application of the rule in 8 to 6. So this particular, what is the compression ratio here? In case of SI engine, it is normally 6 to 10. Pressure increases with increasing temperature. We know that for gases, there is a direct relationship between pressure and temperature. P is directly proportional to T according to the Geluza's law. Yes or no? V is directly proportional to T, your Charles law. P is inversely proportional to 1 by V, that is called your P, V and T are the pressure and volume and temperature of the gases according to Boyle's law. Okay friends. Right. So let us see. So now the pressure goes up to as much as 6000 psi. So this is approximately pounds per square inch. This is nothing but your 41,369 kilopascals. Okay. This means the pressure pushing down the piston may be as much as 4,000 pounds. That means 1814 kg. Okay. So the high pressure pushes the piston down. The downward push is carried through the connecting rod to the crank pin on the crankshaft. So connecting rod and crank are connected by a pin called crank pin, and your piston and connecting rod are connected by a pin called what we call, it is called piston pin or gudgeon pin. Okay, now this means right, the high pressure produces the piston down, the downward push is carried through the connecting rod to the crank pin on the crankshaft. The crankshaft is forced to turn. The rotation motion is carried through shafts and gears to the car wheels. The wheel turn and the car moves. This again, once again, transmission mechanism, friends. Okay, so once the power is generated at the crankshaft, okay, there is something called flywheel, which is going to supply the energy during the deficit, and it is going to take the energy during the excess energy. So it is something like a mechanical capacitor. So after your flywheel, we have a clutch, then we have a gearbox, then you are once again you have a universal joint, then what you call there is something called there is one shaft is there, then you are another, at the other end you have propeller shaft is there, other end you have another universal joint, and then finally you have a differential. So through this system your engine power is transmitted to the rear wheels, right. Alright, so this is how the mechanism goes on. So the correct answer is B. Right, friends. The 4 piston strokes follow each other in the order of. So he is asking the order of piston strokes: intake, compression, power, exhaust, intake, power, exhaust, compression, compression, power, intake, exhaust, exhaust, compression, intake, power. So just now we were discussing. First of all, intake stroke, that is also called suction stroke. During the suction stroke, the present temperature or that of the atmospheric air, normally they will be, normally in the problems we will take 27 degrees centigrade, that is 300 Kelvin, and atmospheric pressure is equal to 1.01325 bar. If any values are not given, you can take these are the standard values. Suction stroke, then after that compression stroke, in which the air fuel mixture is compressed to a very high pressure. At this pressure, a spark is supplied in case of a SI engine, that is petrol engine, in case of your petrol engines or spark ignition engines, and in case of diesel engines we have a what you call injector, fuel injector, diesel injector. Okay, friends. Then after in compression stroke we have got a power stroke, on which during which it is going to, the gases of combustion are going to expand and they are going to create the pressure on the piston, hence the piston moves, and then finally the exhaust stroke. Whatever the combustion gases, burnt gases, they are going to be let out to the atmosphere through the exhaust stroke. But even then, some of the gases are going to remain in the cylinder and they are going to what you call dilute the fresh air or fresh mixture or charge. So let us see, the correct answer is your intake, compression, then power, exhaust. Correct answer is your A. That is also called suction, compression, power and exhaust. Let us see the last question, friends. The overhead camshaft engine is more responsive engine because, so he is saying that there is something called overhead camshaft engine. He is saying that this is more responsive engine. Why? What is the reason for this? Because why? Because of that, the fact that there are fewer parts in the valve train, or the engine is smaller, or the pistons are lighter, or it is a spark ignition engine. The correct answer for this is your A. That is, there are fewer parts in the valve trains. Let us see why. The action is the spark ignition. Action in the spark ignition engine can be divided into 4 parts. Diesel engine operation, of course, this is a different thing. It's altogether different, diesel engine operation. But here, in case of SI engine, each part consists of a piston stroke. Sorry, friends, this is your. We were discussing about the 5th question, right? That is your 4 strokes. That is your intake, compression, that is suction, compression, power and exhaust. So let us see the answer for this. So this camshaft, so he is referring to the camshaft. The camshaft has 2 cams for each cylinder, right? One for the intake valve and other for one for the exhaust valve, right? So we know that the valves are driven by cams and camshafts. Okay, so cams are basically used here. Why cams are used? To give the proper motion. That means rise, dwell and then fall. Your valve has to open up, then stay opened for some time, then it should close. So this accurate motion is reproduced by a mechanism known as cam and follower mechanism. So that's why your cams are used in the opening and closing of the inlet and exhaust valves, right? So now the cam is a round collar with a high spot or lobe. Note that the cams are directly above the valve stems. So this is all your mechanism or composition of the mechanism. The top of the valve stem is covered with a small hollow cylinder called a bucket, valve tappet. It is called a valve bucket tappet because it is shaped like an upside down bucket. That's the reason it is called bucket valve tappet. So when the camshaft and cam rotate, what happens? The lobe comes around and pushes the valve tappet. Okay, the valve stem down. So these two, valve tappet and valve stem, will go down. The valve opens. Because of this, the valve opens. Now, when the lobe passes out from the valve tappet, the valve spindle pulls the valve up so that the valve closes. This is how your valves are opened and closed. Right. Now, engines with the camshaft on the cylinder head are called overhead camshaft, OHC engines. they are more responsive than other types of valve train. This is because there are fewer parts in the valve train. Normally, there are more parts, but in this type of overhead OHC or overhead camshaft engines, there are fewer parts, so that the operation of operating mechanism or opening and closing mechanism of valves is easier or simplified or fast compared to other types of what you call engines, where number of parts for this opening and closing mechanism are more. So the correct answer is here A. Okay friends, so in this video what we have done, we have seen some basic and good questions and tricky questions from your point of view of Assistant Motor Inspector Automobile Engineering second paper. I am offering online batches friends. If you are interested, you can call me on 9912507633 or you can mail me at sridhar.bpl@gmail.com. We will see questions daily which are useful for your examination. Let us meet in the next video.